guys, welcome back to Math Homework Hotline, where we do the math. My name is Maggie Mixon, and I will be one of your hosts this evening.
And I'm Canella Prado, and I'm your other host.
So we have some exciting news, all sorts of things happening here in our studio tonight. But without any other first up, excuse me for a second.
You okay?
That was bad. We are not coughing around here on you being able to call in. Our tutors are on the phone right now taking your calls. So you call in 813-840-7260. We will handle your call on any math topic. And not only do you get your question answered, you get entered into a raffle for a snazzy t-shirt like Canella and I are wearing. Ta-da! And also you can make your teacher a winner because every time you call in, you get a point for your teacher. We have a contest going on for that. We have a winner tonight, by the way, of last month's teacher contest, but we won't tell you that just yet.
Fun announcement coming up.
Exactly. We're also on the go, where we are live streaming on mathhomeworkhotline.com or Hillsborough County School or hillsboroschools.org/MHH. No, that's a little bit longer. But hey, we are going to have some fun. Canella and I are here to do a specific topic. And what's that topic going to be tonight?
Well, our fun theme is superheroes, so let's see what the topic is to go with that.
That's awesome.
Tonight we're going to talk about laws of exponents and a little bit of scientific notation, because you have to know the laws of exponents if you want to do scientific notation. So there you go. It's a fun night for sure.
So you guys, with the topic of laws of exponents, maybe you have a little bit of experience with that, maybe you have a lot of experience with that, but we try to make this so everybody understands what we are talking about. So stay tuned with us. We're getting ready to roll our challenge problem that goes along with this topic.
All right, tonight's challenge problem. It says the distance in kilometers to Proxima Centauri, the closest star to Earth, and I'm going to guess this is true, right? I'm going to say 39,900,000,000,000.
Something like that.
I think I'm pretty close there. That's a really long way in kilometers. Estimate the distance in kilometers to Proxima Centauri by writing it in the form of a single digit times an integer power of 10. So, integer power of 10. Sounds like scientific notation to me.
And single digit.
Yes, single digit. That's what I would underline.
Exactly. So you guys don't forget to take a picture of that so that when it goes away, you can still work on it, especially being that big, ginormous number.
Yes. Lots of zeros.
Lots of zeros. So last week we also had a challenge problem, and that topic was very different than what we're doing tonight. But we have a picture of our challenge winner from last week.
Let's see who
that
it is.
picture. It was in Dr. V's classroom at a school nearby here. So our Demi winner, if you noticed, he was very excited. This actually was taken about 3 hours ago. Actually about 4 hours ago, because that's when I was able to get out there to the school. So I personally come to your classroom. Dr. Von Staten, is there getting some of his goodies. And this was Anish in Dr. V's class over at Williams Middle Magnet. So definitely getting all his prizes. He was very proud. This was at the end of the day, so way to finish off. And I believe we have another shout out.
We do have another shout out. Let's look at the next photo, please. I know there's a ton of third graders at Lowry Elementary that are super excited to see this photo. This is Miss Prado and some third graders from her class. Did we get their names?
No, we did not get the names, but at Lowry Elementary.
Yes, so this is some of her third graders. And secret note here, yes, we have the same name because that would be my daughter, who is a third grade teacher, math and science teacher over at Lowry. And the kids heard about Math Homework Hotline and are now regularly calling in. And she gives them a special challenge question each week to get that applies to like whatever they're learning or what they're reviewing. And so she has them call in and they are loving it.
That is so fun.
And you went out and talked to them, right?
I did. So kids of all ages doing the math out there. And guys, it just makes me so emotional to hear all this great math is happening throughout. Also a big giant shout out because right now, for the first time, we are announcing, I have a little gold star to show that, our teacher winner for the month of January. Actually, Take that
It was
back.
kind of like
February.
Yeah, it was like
February. So we are now in March. I don't know about you, but the year is going
way too fast.
going way too fast. But for the month of February, we had 3 shows, and the teacher with the highest call volume was our very own Miss Height. Yes. So she is our grand winner for the February contest, and she teaches at York. So the full name of their school is Kenneth E. York. I'm sorry.
Adam.
I'm going to say Maggie right now just takes a pause. Adam was the February winner. January was York.
Yes.
So both are K-8s, super proud of them. Ms. Garrison won in our January contest, so at York, and now Miss Height at Adam, both being K-8 schools. Kenneth E. Adam K-8 Magnet. So I apologize for the quick mistake for that name. I just get so excited that our students are calling in, and our K-8s are doing an enormous job of getting their word out there to use our resource. All right. With that being said, we do have a contest right now. This is the last one for teachers for the month of March. So January was Garrison at York. February was Miss Height at Adam. And now we're looking for that third teacher to be our Teacher Demi winner for our season here at Math Homework Hotline. And how do you get that teacher contest? By you calling in. We have 3 shows in the month of March, today being the very first one. Then next week we have another live show. Then we'll be off for spring break here in Hillsborough County. And then our third show will be on March the 27th. All right, so stay tuned for that. Be calling in and get your teacher to be a winner. All right, without any further ado, though, I'm getting my board ready for us to be able to talk about quick intro to our topic of the evening, which was what? Laws of exponents. All right, so let's do it on my board. Guys, the word exponent can also be referred to as the word power. And I would tell you there's a lot of power. That's why we have the fun theme of superheroes, right? But typically you're going to see a big number, and then you have a little baby number. And that's what the kids will refer to it as, the big number. This is called the base, all right? And this E is for exponent, or you may say a power. So what that would look like would be something like this, 3 to the power of 2, let's pretend. So you have the base of 3 with the exponent or the power of 2. What this refers to, it's a shortcut way of writing repeated multiplication. So this 3, don't say it 3 times, you say it the number of times that is up here for your exponent. So that's a 2, so how many times are you going to write out that 3? Only 2 times. So we say 3 to the power of 2, or 3 squared. The reason I put an extra 3 there is that sometimes kids will say, well, you got to multiply times 3 twice, and then they show that twice. Okay, so that's not correct. So you only write it out the number of times that the exponent tells you, okay? So be careful with that. So you see 3 to the power of 2, that means 3 times 3. How many 3's are there? How many bases are there is given to you by that exponent, okay? So 3 times 3 is 9. You can be asked to give it in any one of these forms, all right? So you can have it in an exponent form, an expanded form, or just the number itself, that standard form. Now when we say 3 to the power of 2, that also can mean 3 squared, and that's a special exponent. And there's another one that's called cubed. Now, any guesses as to what that would be? What exponent? So same idea here. I'm going to do, let's say, 5 cubed. That refers to the power of 3. So how many 5s am I going to write out? Look at the exponent. I'm going to write out the 5 3 times. And 5 times 5 times 5, again, that's repeated multiplication. And when you're asked to show it in an expanded form, there it is. And then actually to get the actual number of what it represents, you say 5 times 5, which is 25, and then multiply by another 5, and you get 125.
When I taught the 6th grade, I kind of use this as a hint. I would say that a cube, like a Rubik's Cube, is 3D.
Oh, yes.
Like 3D. And a square is just a flat, like a piece of paper. Flat, it's 2D.
Exactly.
So that's where I said, help them to remember which one is 2 and which one is 3.
So this is 3-dimensional, cubed, and this is
squares, just 2-dimensional.
Very nice.
Yeah.
All right. So with that little warm-up, we're getting started talking about those powers and now the laws of exponents that go along with this. Kenella's going to kick us off.
Yes. So there's a lot of laws of exponents, but You know, if they kind of make sense when you have them all together, but I'm going to start with the first one, which is the multiplication law of exponents. So if we can go to my board, we've got evaluate the expression 5 squared times 5 to the 5th power. One of the things that I really feel that kids still struggle with in 7A is remembering that parentheses means to multiply. Okay, so I wish we would start teaching that back in 3rd grade, like the little kids at Lowry, so that they would know that when you see 2 numbers in parentheses, that means to multiply. But what this would look like is I'm going to show you like the expanded form way, and then I'm going to show you the shortcut rules way. So we have 5 squared. So that, again, that means we're going to do the base times itself 2 times. So there's that one. Then this one would be 5 times itself 5 times. Okay, so there you go. So now you can always stick with the expanded way. It's not a real problem until you get into exponents greater than maybe 10, and then it can get sticky. But basically what you do then is you count how many 5s you have here. We have 1, 2, and then you could put a dot there, 3, 4, 5, 6, 7. So it would be 5 to the 7th. That's using the expanded form way. Okay, so now there is a law, and the multiplication law of exponents says that as long as they have the same base, and I always say base, big, so the big number, as long as they have the same base, which we have here, the base is 5, you can add the exponents. Add the exponents. So that's your first rule for tonight. The multiplication law of exponents says the same, if they have the same base, add the exponents. So what that would look like is I'll grab another color here. Let's try this. I'll go with this. We'll see, hopefully this light blue is a little bit different. It's kind of different.
Orange.
We'll go with orange. We're getting all Florida Gators on you tonight.
Ooh.
Yeah. So it would look like 5 squared plus 5 squared, or to the 2nd power, plus the power of 5. So it would look like that, and you would get 5 to the 7th power. So look, whether you do it the expanded way, or as I like to say, the shortcut cheater way, using the law, you will end up with the same number. There you go. And I guess go Gators at this point.
Go Gators.
Right? Oh, you're go Gators too.
I am. So guys, one of the things that we were saying from the very beginning is, yes, doing these laws of exponents, and yes, getting that challenge problem. You know what? We want you to win. Nobody's called in yet with the answer to that challenge question.
That's right. Give us a call.
Canella, what kinds of things are they going to win?
Oh, yes, absolutely. They're going to win a T-shirt like us. Because, you know, we like to have a lot of people out there with our T-shirts. A great little bag. This is perfect for gym clothes, literally anything. Little things you need to take extra to school, whatever, you know. Pencils, because I don't know what's happened to all your pencils. I went through 48 in 2 days in my class. We get you some free Domino's and some free McDonald's. And of course, the big one of all, which is the plaque from Ed Gems that says you're this week's Jemmy Award winner on the challenge problem. So lots of good stuff, especially free food, because we all know that middle schoolers and high schoolers are growing.
Growing children.
Growing children. And also pencils, because...
Bragging rights.
Yeah, bragging rights. And pencils, because where are your pencils?
Yeah, exactly.
They're not in your backpack.
So guys, we don't have a winner yet, so you be calling in.
Call us in.
So we were trying to incentivize you, show you all the great stuff you're going to be able to
Yeah,
win.
absolutely.
As you're getting that question prepared. Talking about questions prepared, I have another one on my board. And as Canella was referring to, this is maybe a superpower, but we have here the Florida Gator colors to share with you. Equivalent to 1 over 2 to the power of 3 question mark. So that's our next problem. So guys, maybe you see something like this where literally it could be in the form of a table, and it's going to ask you, is it equivalent or not equivalent? And you got to figure out which one is going to be the same as the one given to you. Now, what I see at first is that, first of all, my number that I'm shooting for looks like a fraction, okay? Not only does that look like a fraction, there's an exponent in the denominator spot. So some things that we haven't talked about yet that we're going to go through as we talk through these different pieces. When I have a negative exponent, that's going to look like literally 1 over 2 to the power of 3. Look what happened. this entire parentheses now became my denominator. So I could have had the parentheses right next to the 2. And now because it went all to the denominator spot, that exponent stays where it is next to the 2, but now it becomes a positive instead of a negative. So with negative powers, literally all it's looking like is a fraction. And how many of us really like looking at fractions? I don't think a whole lot of people do. Not that negatives are always the best second choice, but it is. So this is just another one of those quote unquote rules. And when we have a negative exponent, that really just refers to looking at really a fraction where that base with its power really is the denominator. All right, so now it just becomes a positive. Now it gets a little tricky when you have that negative at the bottom. It just really reverses everything from where it's at. So we'll talk through that as we get to it. Now my question is this equivalent to or equal to with the number that we were trying to target? The answer is yes. So that's exciting. That is equivalent. Now here is exactly what Canella was referring to. When you have two numbers that are being multiplied with the same base, we're going to use that shortcut rule of adding your powers. All right, so this was 6, and I'm adding it to a negative 2. I could have also done 2, 6 minus 2. All right, so that looks like 6 take away 2 is 2 to the power of 4. So does 2 to the power of 4 look anything like 1 over 2 cubed? The answer is no. So that one is not equivalent. Let's take a look at the next one. Very similar again to the rule that Canella just shared with you. Same base, I am multiplying, so all I have to do is add my powers together. And we can show that in expanded form if we need to. But here, use that shortcut because it definitely helps alleviate some of that stress of dealing with big fractions or little fractions of any kind. Or here, all I had to do was a negative 6 plus 3, which was what? 2 to the negative third. Wait a minute. 2 to the negative third sounds a whole lot like this first one that I was working with. So that's definitely going to look like 1 over 2 to the third. So that one is indeed equivalent. A couple more to do with us. Here, there's an invisible 1, okay? So the 2 doesn't look like it has an exponent. So when it doesn't look like it, there's an invisible 1 sitting right there because it's just 2, right? So same base, I'm going to add my powers, which is just the 1, so negative 4 plus 1. Wait a minute, again, that looks like what I was working with from the very beginning, 2 to the negative third, which is 1 over 2 cubed. And then lastly, this is a little bit different. Here's the power raised to a power. If I were just going to write that out, it'd be 2 to the second, or 2 squared times 2 squared times 2 squared. That is not repeated addition. It is repeated what? Multiplication, right? So here with a power raised to a power, we're actually going to multiply. So it looks like 2 times 3, raised to the 2 times 3 power, which is really now 2 to the power of 6. So does that belong and is equivalent? The answer is no. So just make sure that you're working through, what does the negative mean when we have the same base adding? When you don't have what it looks like an exponent, that there's an invisible 1, and a power to a power, you multiply, not add. All right? We do have a caller on right now, though. Who are we speaking to?
We're speaking to Michelle, I think. Is this Michelle?
Yeah.
Hi, Michelle. And you go to Benito and Miss Applegarth's class?
Yeah.
All right, yay. And I hear you're our challenge winner. Is that right?
Yeah.
All right. Well, we're crazy proud of you, Michelle. You're going to be getting all kinds of good stuff from Maggie in the next week or so. So let's go to the board. Let me read it to everyone back at home so that they can know what we're talking about. And then we'll have you do the work, okay? All right, it says the distance in kilometers to Proxima Centauri, the closest star to Earth, is, I'm going to say 39,900,000,000,000. Estimate the distance in kilometers to Proxima Centauri by writing it in the form of a single digit times an integer power of 10. Now, I gave a little hint, right? And I said that you would write this in scientific notation with some rounding. Is that what you did?
Yeah.
Okay, so tell me how you came up. Tell me what you said the answer was.
I said the answer was 1 times 10 to the power of 13.
Okay, let's start with, well, you tell me what you would like to start with. Would you like to start with the power of 13 or the 4?
The 4.
Okay, tell me how you got the 4.
I got the 4 because I put the decimal at 3.99.
Okay. You put a decimal there, and then you just rounded it to the nearest single digit, right?
Right.
So that gave you a 4 with a bazillion. I'm going to have to try to keep track of all these. Maggie, help me keep track.
I'm trying.
Okay. Did I get them all?
Put your commas 1, 2, 3, 1.
1, 2, 3, 4.
Yes.
1, 2, 3. Okay. So you basically, and then you put your decimal here, right? Okay. Now, how did you come up with 13?
I went back 13 spaces until I got to the original decimal.
Okay. So you started at the back, and then you counted how many zeros going all the way forward, right?
I think she did it where she moved
Yeah.
the decimal. Or yeah.
Okay.
Either way.
So, we would have, there would be 3 here, right? Okay, and 3 more would be 6, and then 9, right? And then 12. We see every place value counts as 8 times 10, right? Because everyone represents a place value of times 10. Okay, so we got to 12, right? And then we went 1 more to get 13. Yes?
Yes.
Okay. So, and I'll go ahead and do it in black here really quick. You can literally, put dots. I mean, I teach kids to do dots like this over it, or bunny hops. And then that way you can keep track, because it is really easy to lose track of all those zeros. So I say mark it in some way. Put a dot over it. You could do bunny hops like this.
See, and I like the bunny hops, but I like to start at the decimal and move out.
And you like to work backward.
Yeah,
Okay.
so
1. Oh, my black. We do not have a black marker.
Let's do orange.
Okay. We're going with Go Gators tonight.
Okay,
1, 2, 3,
4, 5, 6, 7, 8, 9, 10,
11, 12, 13.
Because my thinking on that, guys, is I find the decimal and I'm like, where are we going?
Yes.
Right? So it's 13 places out.
Right. So there you go. And whenever we're taking a big number and making it little, we have a positive exponent. And if we have a little number and we're making it big, it would be negative. So
Yay.
You did outstanding, Michelle. We're very proud of you. Good job.
I'm sure Ms. Applegarth is watching and she's very proud of you as well. Congratulations, you are a superhero Demi winner
That's
of the night.
Way to go. Congrats.
You guys keep calling. Remember all those prizes for you? Now, Michelle took the Demi, but you can still be a winner as well. Canella has the next question for you, and she's super excited because we know that she's going to give you something fun to remember.
Okay. Well, I hope so. Here we go. I hope so. I'm really struggling with the markers tonight, so we'll see how this goes. All right. So it says, for the expression below, determine an equivalent expression written as a common factor multiplied by the sum of 2 algebraic expressions.
That's a mouthful.
Basically, they're saying to factor this. And I'm going to choose to go with the greatest common factor because that is what I see my kids really working hard. Oh, I'm sorry.
It's okay. Just do that one.
Well, we are going to do this one, but first this. I was confused because of the other problem. Okay, but first this, but we'll get to that other one.
We were just kind of foreshadowing
Yes,
where you're
little
going to get
sneak
to.
preview. Okay. All right, so we're going to simplify the expression. We're staying here with our exponent rules. And this one gets pretty complicated. In fact, my kids in my class today were working on one almost identical, except the numbers were different today. Literally, other than that, it was identical. So,
Hey, you have a caller to help you.
I do?
You do.
Okay, hi, caller. Who is this? Can you give us your first name only?
Nico?
Hi, Nico. Oh, good, Nico. You're going to be, Nico's in my class. And Nico, literally, we're going to do a problem just like we did on the review. Are you ready?
Hopefully.
Yes. He's like, I don't know. The review was kind of rough, Miss Fredo. Let's go to the board. Okay, my board.
Other board.
Nico's going to be like, I want to do that one.
So guys, Nico's on the air with us.
Okay, there we go.
And he's going to do this problem with simplify the expression before we go to the one that you just saw.
Okay, so Nico, the first thing I like to do is I like to go ahead and just group my numbers, my constants. In this case, they're coefficients, right? But we're going to take 16 over 320, okay? So I like to kind of just group them out. And then we could do x to the 1. Remember, when there's nothing there, there's really a 1. And then we can do y to the 5th over y to the negative 3. Okay? So I like to kind of group them out because what I've noticed when we get into these big problems, kids will forget one. They'll just lose the x altogether or suddenly poof, the y is gone. All right, so I like to break them apart and then put them back together at the end. So Nico, do you know how to simplify 16 over 320?
We do 16 divided by 320.
Right, so, or you could do grouping, like you could do how many groups of 16 are in 16, right? So how many groups of 16 are in 16?
One.
Yeah, he's like, is this a trick question? All right, how about how many groups of 16 are in 320? So you take 320 and divide it by 16.
I got 20.
Yep,
Very nice.
perfect. All right, so we got that part done. So now do you remember with division of exponents what the rule is? Because we haven't learned that yet, so I want to write it out. Division, law of exponents with the same base.
So with multiplication, we add the exponents. What do you think we're going to do with division?
So what do we do with
We would subtract.
subtract?
Very nice. And you have not learned this yet.
Subtract the exponent. Oh, yes, he has.
Oh, he has? Oh,
Yeah.
Nico, good job.
Yeah.
Good job remembering. You're a superhero right now for this question.
All right. So then I kind of like at this point now, I'm going to go ahead and leave this in a fraction, but take this out of a fraction temporarily. So I'm going to do x to the 1 minus 4, right? Okay. And then let's keep going down and let's do the same thing to the y. So the tricky part of the y is what? What do you think people forget on the y?
People usually do just 5 minus 3.
Exactly. When it's really 5 minus a negative 3, right? So then we get that broken addition symbol. So what do we really need to do with those?
5 plus 3.
Yes, exactly. Okay, so I'm going to start rewriting again. I'm going to write my 1/20th. And then x to the 1 minus 4. What's 1 minus 4?
Negative 3.
Okay, and then y to the 5 plus 3 would be what?
8.
Yes. Okay, so now all I have to do is kind of look at this and go, is there anything else I need to do? We're very close to the bottom. We have a negative exponent, so we got a new rule. So negative exponent. Do you know what the rule is for it? Remember, I like to I'm going to tell the story really quick now so that the kids at home can get the story too and you can remember, okay? So sometimes at school when a kid acts negative, we send them downstairs, like in our school it would be like Miss Stare's room, and then that makes them positive. Like they go down there, they refocus, and they're able to get their work done. And the same thing might happen in Miss Stare's room. A kid might be acting negative down there, so we send them up to Miss Prado's room upstairs, and then they become positive. So the negative exponent rule says that whenever we have a negative exponent, we change, what is I'm trying to say? What am I trying to say here? We do the reciprocal, okay? Mm-hmm. So change location, do the reciprocal. Change location means reciprocal, right? And reciprocal means flip it, right?
And?
Yes.
Okay, so what's going to happen then? So what are we going to do with that negative? He's negative, so where's he got to go?
He's got to go downstairs and turn into a positive.
Yes, exactly. So we move him down. Oops, a little bit low here. There we go. So we move him down, and he becomes positive. How about y to the 8th? Is he being negative?
No.
So he can stay upstairs, right?
Yes.
He's upstairs because these are really just all over 20 at this point, right? So then we move the x to the bottom. And then do we really need the 1 here, Nico? We've got 1y to the 8th. Do we?
We don't need it.
We don't need it. We can get rid of it. It's not wrong if it's there. It's just not necessary.
Vanilla, when you guys were writing the negative exponent rule, change location, and then do you also switch the sign?
Yeah. Oh, yes. And make positive. Thank you. Make positive.
But if it's, yes. And make
Yes.
positive.
We talked about it, but we didn't write it.
Correct.
There we go. So, and make positive. And make positive.
There you go.
All
Nico,
right.
you did so amazing.
Yes. Thank you, Nico. Good job calling in. See you tomorrow.
That was a lot of steps, you guys.
Yes, it was.
And that's why we needed to do that question before we did some of the other ones. All right, so we're going to find the product next. And this one is the one that you had seen a little preview of before. So one thing to notice, guys, is that I have a parentheses. I have some decimal values, which is crazy, right? And not only do I see a letter, that variable h, outside of the parentheses, but also on the inside of the parentheses. Now I'm going to recall that when we do and see something like this, we are talking about distribution or the distributive property. And with the distributive property, we're going to multiply everything on the outside of that parentheses into everything on the inside of the parentheses. So we're literally going to take, taking and multiplying times 5.2h, both of these terms. All right, so you're saying 5.2h, and it's going to be multiplied times 2.1. I'm going to bring that addition sign down, and you're going to take the 5.2h, and you're going to multiply that times 3.8h. Truth be told, when I'm doing this myself, I don't usually write it out like this, but for our purposes, so we could see the math, where I'm multiplying times each term, I'm showing it to you that way. So here, 5.2 times 2.1. So the coefficient, that number, is just going to multiply times that constant, and I'm going to get a decimal of 10.92. Now, what are you going to do with that h?
Smack it on the end.
Exactly. So h times, there's nothing else there for letters, so it's just going to be h. So literally, that's all you do. Multiply the numbers, smush the h back behind it, right? Same thing's going to happen over here. 5.2 times 3.8, I'm going to get 19.76. Now, be careful. H times h. So literally this is saying h times h. So same base, don't forget, even if it's a variable, that's okay. So same base, I'm going to add the exponents, so 1 plus 1 is 2. H times h is just h to the power of 2. All right, so literally this becomes
Thank you for showing that, because that is like one of my kids' biggest issues, and I also have to do that, h to the first times h to the first.
And right before we take another caller, guys, this is another one of my pet peeves. When you're actually writing the final answer, the most correct answer is what we call in standard form, if you will. The h to the power of 2 comes before the h.
Yep.
So like think of it like the one that has the highest power
should
goes
come first,
and then the second one. But are these equivalent forms?
Absolutely.
Absolutely. All right.
Especially because the commutative property of addition.
Exactly.
Yes.
We have a caller on. Who are we talking to?
Can you tell us your first name, caller?
Sophie.
Hey,
Sophie. Hi, Sophie. Okay, Sophie, so I did a sneak preview of this on accident earlier, but now we're going to dive into factoring. Are you ready?
Yeah.
Okay, so I'm going to give your screen a second to catch up, and I'm going to read it. It says, for the expression below, determine an equivalent expression written as a common factor multiplied by the sum of two algebraic expressions. Now, this is a fancy way of saying factor this out. And Sophie, I want you to focus today on factoring with the greatest common factors, because I find that kids find that challenging. So where would we start, Sophie? Do you have any idea on this algebraic expression with two terms, 8x to the fourth power plus 9x to the fifth power times y squared? What should we do first? What would we factor out first?
The greatest factor.
So
Yes,
we would factor out the number first, right? The coefficients in these case, 9 and 18. And I always tell you did it right. She said 9. But I like to go ahead and explain how to start that, just for kids at home that aren't as quick as you. So always look to the little guy first, which is 9, and ask yourself, is it a factor of the large one? And yes, in fact, 9 is a factor of 18, right, Soph? So we know if the little is a factor of the big, you found the greatest common factor. You can be done there. So we're going to pull out the 9. Now, Soph, what we're going to do next is we're going to look at the little guys, the x's, okay? So the x's here, you'll see this one is to the fourth power, and this one is to the fifth power. So how many x's can we take out? 4, that's right. You can always take out the smaller value. That's the maximum you can take out. Now, how many y's can we take out? How many y's could we factor out?
None.
None, because why? Do you know why? Can you tell us why, Sophie? You're right, but...
Because there isn't a y on...
Yes. Yes, the first term doesn't have a y, so we can't factor any y's out. That's exactly right. So now we go back to our factored out term here, okay? And we say, how does 9 become 18? What would we multiply? Because this is multiplication because we're distributing, right? So 9 times what is 18?
2.
2. Now, I always tell the kids now, look to see how many more x's would we need, okay? We have x to the 4th outside. We're going for x to the 4th. Do we need more x's?
No.
No, right, because when we multiply 9x squared times 2, we'll get 18x to the 4th, okay? So 9x to the 4th times 2 would be 18x to the 4th. So we're good there. So now we're going to put our plus sign in, all right? 9 times what would equal 9?
1.
1, exactly. So we can write the 1 for now just to so that we can say that we did it, all right? Now we have 4 x's on the outside. What would we multiply it by to get 5 x's? How many more x's do we need?
1.
Yes, exactly. Okay, and then we have no y's out here. So how many y's do we need to multiply by?
2.
Yes, y squared. We got to bring the whole thing down because if we don't, it won't be there. So now to make it really proper, get rid of the 1. We don't need it, right? So, and just to show this back again, we would just make sure when we multiply it back, and I'll check your work. You did it perfect, but let's just check. 9 times 2 is 18. Bring over the x to the 4th. And then we're going to take 9x. 9x times 1 would be 9. And then x to the 4th times x to the 1st, remember there's really 1, would be x to the 5th. And then we just bring down the y2 because when we multiply it, there's nothing to add it with or combine it with. So there you go. So you did it perfect, Sophie. Thank you. I'm so proud of you. Awesome
This
job.
is showing the greatest common factor,
That
guys.
was the greatest common factor,
So,
yes.
and sometimes remember, depending on the question, you may not necessarily have to take out the greatest common factor. You may just need to do an equivalent
Right,
form.
so you could have done 3x squared on the outside, or
Exactly.
even just 3.
Right.
Right.
But a lot of
Or
times to
just
be
9.
in simplest form, you want that for sure, that greatest common factor.
That greatest common factor.
All right. And Canella, we have some T-shirts to give away.
Woohoo!
Camilla at Lowry, Joseph at Junta, and Bailey at Farrell. Congratulations. And this now brings us to our Gemmy, our gem of the night from Ed Gems. Notice that you're going to see the target tracker, which is a self-assessment tool. It's reflection on your skills, setting goals for the unit, and tracking your progress. So you look at these little thermometers. This is basically printed in the student workbook. You can find it digitally as well, though. And it's really designed for students to visualize the expectations, set goals, chart their progress as you go through that learning. So every lesson has a little thermometer, and you start gauging. That digital interactive version is definitely there. Your feelings, how hot are you feeling on this? How good is that progress within that skill? So very excited for that. So thank you, EdGems, for our target tracker, definitely used in the classroom. Guys, this means that we're about halfway through our show. So we are going on to start talking about scientific notation. Now I'm going to tell you, we add that topic here when we talk about laws of exponents because think of it as an application. It's like the next thing that we do. So have you ever had a really, really small number? Like tiny, like 0.00000, and then some number like 2. Or the number that we saw in the challenge problem tonight, that was, Canella spoke it out in the trillions place, right? Something really, really big. So we have really, really big numbers and really, really tiny numbers. There's a specific way that we write those numbers, and it's called scientific notation. So the notation means just a way of writing. So what we're going to do is we're going to go from what we call standard form, like the normal way of writing the number, to scientific notation for 2 of them, one being a small number, one being a larger number, and then backwards from scientific notation into standard form. So do not make this more difficult than it's worth, if you will. For scientific notation, you're going to have the digits from 1 through 9, followed by a period, and then times 10 to some exponent, okay? And that exponent is going to then reveal how many places do you move the decimal. So it'll look something like, for instance, 1.2 times 10 to the 3rd. And that means that I would move the decimal 3 spaces to the right. All right? So scientific notation, what it would look like is a number, the digits 1 through 9, a period, Most of the time, you have other digits behind it, like 3, 2, 1, 4, whatever it may be. I'm just making these up. Then times 10. The 10 does not ever change. The times doesn't change. And then what changes is this power right there. The power is going to tell you where to move the decimal. If it's positive, you're going to go to the right. And if it's negative, you're going to go to the left. All right? Very, very specific way of writing things in scientific notation. So we're going to practice just real quick. Here, the standard form is 0.0012, or you see this number and you say it's a small number. We talk about significant digits. The only numbers that are quote unquote significant are the 1 and the 2. The other numbers are really placeholders, if you will. So we're going to look like 1.2 times 10. Now be careful. How many times did he move the decimal to make it look like it's behind the 1? Bunny hop 1, 2, 3. Put a 3 right there to start with, but let me ask you, when I was moving my decimal place in, if I were to go from scientific notation back into what their actual decimal looks like, where is that decimal moving? To the left or to the right? So from scientific notation and put it back into standard form, I'm going to have to move the decimal to the left, so that direction is given by the negative on that exponent, okay? So similar to what Canella did when she factored and then she multiplied it back out to see if the distribution property would work and give you the original. Same thing here. I look at my scientific notation. If I were to move 3 spaces to the left, would it give me this number here? So 1, 2, 3, the answer is yes. So that's how you would do that one from standard form into scientific notation. Take a larger number, like 345,067. To put that in scientific notation, I have 1, 2, 3, 4, 5, 6 numbers. They're all significant digits. I don't see any specific placeholders. The placeholders are going to be either zeros in the way front or zeros in the way back. This 0 is significant. It's smushed in the middle of all the different numbers. So to make it look like the form of scientific notation, I'm going to put my 3, my period, put all the numbers that are significant, all of those numbers, times 10 to the something. All right, so where's the decimal here? I don't see a decimal. This is actually a comma, right? So the decimal, when it's invisible, is sitting all the way in the back. So move my decimal 1, 2, 3, 4, 5 places. So that's going to be my exponent. Now, am I going to leave it positive or am I going to make it negative? Don't forget, if the decimal is right there and I need to move it back into standard form, am I going to move that decimal to the right or to the left? Since it's a big number, I'm going to move it to the right, and I would have been 5 spaces. 1, 2, 3, 4, 5. So I know I'm going to leave that as a positive. So in general, a blanket rule, if it's a small number, you're going to see that negative exponent. If it's a large number, you're going to see the positive exponent. So let's go in reverse from scientific notation into standard form. Here we go. My decimal is behind the 2. To make it look like standard form, like the regular number, I'm going to move that decimal how many spaces? 6. Am I moving to the left or am I moving to the right? To the left, because that's a negative, right? So literally, guys, what I end up doing is I put in a bunch of zeros, and I might have to erase some of these zeros, but I just put those in for now because I say, okay, 218 is definitely going to stay. The decimal is currently sitting right here, and I have to move 6 spaces that way to the left. 1, 2, 3, 4, 5. Oh my gosh, I put in the correct number of zeros. And I'm going to put that leading 0 in there to make it obvious.
Where the decimal is.
With the decimal, exactly. Where that decimal is, to point out that that decimal definitely shows right there. And I do it one more time. 1, 2, 3, 4, 5, 6 as a check for myself, because as a good mathematician, we want to double check ourselves. And then lastly, we have, again, a number that has a lot of significant digits. Those zeros are definitely significant because they're there in the middle. They're not way in the beginning and they're not way at the end. And I'm moving 8 spaces to the what? It's a positive exponent, so I'm moving to the right. So if this decimal moves to the right 8 spaces, I'm going to say, let me put in the numbers first, and then let's do our bunny hops from there. All right, so 1, 2, 3, 4, 5, 6, 7. Wait a minute, I need one more, so what am I going to do? You add in that 0. Okay, so literally it's like the decimal sitting right there. So 1, 2, 3, 4, 5, 6, 7, 8, absolutely. And then I get rid of that because I don't need that decimal at the end, but I do put in my commas to show the different place values. And there you go. That's your quick lesson on going from standard form and scientific notation and back.
Okay. All right. I have one of our favorite story problems.
Ooh.
Yes. So we're going to do a story problem with scientific notation. It says Superman had 0.0035. So that would be what? 35,000 pounds of chocolate. Spider-Man had 3.5 times 10 squared pounds of chocolate. How many more times? How many times more pounds of chocolate does Spider-Man have compared to Superman? Okay, so I'm going to put Spider and Super. I'm going to abbreviate right now. Okay, so how many more times? Many times more. Many times more means to divide, okay? So we're going to put in Spider-Man, and he was 3.5 times 10 squared. And we're going to put a division symbol, which is a fraction bar in this case. And then 0.0035 is what Superman had. So all we got to do is divide this down. Now, I will tell you, a lot of my kids really prefer to go the safe route, which is just to turn it into standard notation. And I have no issue with that. So I'm going to write my 3, and then I'm going to start counting with the 5 because we have to move over 1, 2 bunny hops. So there would be 1, 2. So again, like if it were here, we'd go 1, 2. So it's 350, and we're going to divide it by 0.035. There is absolutely nothing wrong in the world with getting your calculator out at this point. We're in big people stuff here, dividing scientific notation. So there's no reason not to just go right to your calculator. And you take, remember, but this is something I'm still dealing with my kids. We go top to bottom. 350 divided by 0. Oh, sorry, I missed a 0. 0.035. Okay, and so when we do that, when we divide that out, we're going to get 100,000. Okay, it doesn't say to put it in scientific notation, so it's just 100,000 times more, right?
Yes, ma'am.
That's basically it. So 100. So gosh, Superman has 100,000 times more chocolate than Spider-Man. I feel kind of bad for Spider-Man.
He's gonna be fine.
Yeah, that's right. He'll be fine. All
so
right.
T-shirts are next, Canelo. Who's getting more shirts?
I don't know. Oh, I see Justin from Collins and Divine from Progress Village. And I'm going to say Layla at Lutz Prep. I'm going to guess, right? Lutz Prep? Just Lutz. Layla at Lutz. All right. Thank you guys for calling in. That T-shirt's coming your way or straight to your teacher. Thanks for calling in.
And Canela, we have our second sponsor of the evening. We're going to highlight.
Yes, we're going to talk about Mathnasium now. So let's go ahead and roll that highlight video.
So what is your favorite part of being a math tutor here at Mathnasium?
So, other than the cool t-shirts, I mean, come on now, the shirts are pretty cool. But
Yeah.
I would say other than that, I think I really enjoy helping kids. I just overall, just the joy of making math seem more like a fun topic rather than a subject or a task where you need to, really bang your head against the wall for it. I think there's ways to make math fun. And I think that's what I like the most. Making kids see the good parts. Sometimes there's bad parts, but I think making kids see the good parts of math is my favorite part of this job.
Yay!
Thank you, Mathnasium. You can see from our highlight video here, you can see glimpses of, I guess this was Brandon West.
Yes, ma'am.
Mathnasium gives students the instruction they need to catch up, keep up, and get ahead so they can feel confident that they're on track for a successful year. Schedule a free assessment at mathnasium.com. And remember, they're located everywhere. Brandon West, Carrollwood, New Tampa, Riverview, South Tampa, and West Chase. All right, thank you, Mathnasium.
All right, guys, now that we showed you scientific notation, and we showed not only how to write it from scientific notation in standard form back and forth, we also showed with Canela how to compare. Now we're going to talk about add, subtract, multiply, and divide. So that's what you'll see next. On my board, I actually have it split a little bit. So you see the addition problem on the left, which has already been worked out, and I'm going to talk through that as we go into and then do together the subtraction problem. So here, notice that the numbers are put encased, if you will, within the parentheses to show that entire scientific notation. So 1.3 times 10 to the third is being added with 3.4 times 10 to the fifth. Now, if you're the kind of person that wants to go ahead and put it into standard form first. Remember, you just took that decimal, moved it out the number of spaces that it said, 3 to the right, move that decimal here, 5 spaces to the right. So 1, 2, 3, 4, 5. So if this was what you had been given, just in regular old number form, you know that we have 1,300 being added to 340,000. So that's 341,300. And you would have gotten this. Now, if you happen to zoom into my calculator, you would have seen that. But here, sometimes the answer is given in the form, just standard form, or sometimes you have to write it in standard notation. So you would move it back 1, 2, 3, 4, 5, 3.413. That 3 is still significant, times 10 to the 5th. Now, the reason I have my calculator out is I want to show you, because we also want to give you true things to do in the classroom. There is a button that I am pointing to here that you may not necessarily see in your screen, but it is the EE button. And that actually does these exponents for you, the scientific notation. So I'm going to show you, using our second example, how to do this on the calculator, okay? So I literally have 2.8 times 10 to the negative 4th being subtracted by 3 times 10 to the negative 2nd. My calculator, I'm going to put 2.8, literally going to type in the 2, the period, the 8 to put that number in, and then I'm going to hit EE, and that's going to make it so that the only thing I'm going to need to enter is then the negative 4. So then I'm going to put in a 4, and then I'm going to turn that into a negative 4 with my plus minus key, okay? So literally, I'm doing that right now. 2 period 8, EE, so it shows me now on my screen 2.8 with little zeros up here, all right? Now I'm going to make that exponent what I wanted it to be, the negative 4. So I'm going to put in my 4, make it a negative. Now I'm going to subtract my second number. So minus, what happened on the calculator, it literally shifted to this, 0.00028. So when I put in my negative 4 right here, and then I hit subtract, it changed it to the standard form. So that's kind of cool, right? Mm-hmm. It does it for you. So then I'm going to do my next number, 3, hit the EE. I'm going to put in a what? A 2, make it a negative 2. And now I'm going to hit equal, and it shows on my calculator screen negative 0.02972. Now, I don't know about you, but we're talking about putting these in scientific notation. So not necessarily having the number just in standard form. So when we turn that standard form back into scientific notation, first off, this was a negative number, so definitely leave it as a negative. So negative 2.972, move the decimal 1, 2 spaces, so times 10 to the negative 2. So you could either have that as your final answer or this, depending on what's being asked. Again, I was just showing you how to use those calculator tools because it is definitely a help and a tool for us to be able to do scientific notation in a check.
Absolutely. I taught my kids that this week and they were very excited. But I'm going to show you what to do if you're in the test and you got the answer and you don't feel like it's right and you want to check it real quick manually, or if you just have a panic moment and can't remember the EE button, okay? So let's go to the board. We got 2 things here. It says, what is the value of the expressions in scientific notation? So the first thing I like to do is I like to go ahead and just group the 4 times 3. Okay, so I like to group the numbers that are not powers of 10, okay? And then I do the exponent rules for these are being multiplied 10, same base. So since they're being multiplied, we can add the exponents. Okay? All right, so now we know that 4 times 3 is 12. And then we're going to say times 10 to the 6th. Now, be careful. This is where you'll mess up, okay? You can only have one number in front of the decimal, so we cannot have 12, right? The decimal's there. That's 2 numbers. So we're going to go over 1 here, and that gives us 1.2. And when we go 1 to the left here, here's the trick, okay? If we go to the left on this side, we have to go to the right on this side. So what is the next number to the right on the number line? It would be 10 to the 7th. So it's always the opposite. If you went to the right on this side, you'd go to the left on that side. So you'd go to the left on the number line. But in our case here, we were going to the left over here, so the right over there. So that's a quick way. And then, of course, you could use your calculator. That's fine. All right, same thing here. I'm going to group 2.4. I don't know why that decimal was so high. 2.4 times 7.5 together like that. And then we're going to do 10, then we're going to group together 10 to the 2 plus 4. Remember, they're multiplying, so we can add them. So I'm doing just the top part right now. So when we do, I'm going to really quick look at my sheet here. We get 18 times 10 to the 6th power, right? Because again, we're just adding those. That's the exponent rule. And over here, we just turn this into a number. Okay, so now we have 18 times 10 to the 6th on top. And on the bottom, we have 4 times 10 squared. So all we have to do here is, again, I'm going to group like I did earlier with Nico. 18 divided by 4, and then it would be 10 to the 6 minus 2. So there you go, 18 to the 4. So all we got to do is 18, not 18 to the 4, 18 divided by 4. So when we take 18 and we divide it by 4, what we're going to get is we're going to get 4.5. And that only has one number in front of the decimal, so we're looking good. And the one number in front of the decimal has to be between 1 and 9 inclusive, okay? So, and then 10 to the 6 minus 4, okay, would be 10 to the 4th. And there you go. Let me make my 4 look a little bit better. So then we end up with this one, 4.5 times 10 to the 4th. Remember, one number in front, 1 through 9 inclusive. Our exponent has to be a positive or negative whole number, an integer. And we did it. So there's both of those. We did a complex multiply and divide, and we did a regular multiply. All right, Maggie, what have you got?
I'm actually just going to leave you with a question that I want you to do on your own and show your teacher. I'm going to leave you with a cliffhanger. How's that? So I'm going to give you a story problem, and I'm actually going to give you the answer as well.
Oh, cool.
And I want you to be able to go back to your teacher and show how you did it. All right? So Flash, we have two superheroes. Superhero Flash can run at a speed of 3 times 10 to the 2nd miles per hour. Mm-hmm. Also, Speedster, they're going to run against each other, okay? Superhero Speedster can run at a rate of 2 times 10 to the 2nd miles per hour. They're fast, okay? So they're going to take a little bit of a race, and they're going to start running at the exact same time, okay, from the same point, and they're going to head towards a city that is 400 miles away. Got that? So they're starting together. One starts running at this speed. The other one starts running at that speed. Question is, how much sooner will Flash reach the city compared to Speedster? So the final answer is 40 minutes sooner, but I want you to be able to show how you did that.
There's a couple different ways.
There is a couple different ways. You can find the difference.
Take 400 and divide by each.
Ooh, we're giving some hints out.
Yep.
Now the thing is, guys, one of the clues that I want you to work with is where it says miles per hour. So how is that going to be considered?
I would say divide.
Oh. And then here again, miles per hour, and then you're traveling 400 miles.
Yep.
So think about the time versus the distance. The answer is this. This is the answer, but I want you to show and see for yourself how you would get that, and then we'll come back. All right.
A cliffhanger challenge question.
Cliffhanger challenge question for you. All right, so next week we will be back. Canella, what are we going to be doing?
We're going to be doing circles with pie.
Very nice.
Not eating pie, but that would be fun.
March 14th, Pi Day, guys, 3.14. So we love to celebrate around here.
Right.
And we love to celebrate you as well doing that math. Don't forget to show your teacher that problem. And we will kick off doing some great stuff next week, like spring break, the week after. Go Lightning!
And we love pie.
We love pie.
All pie, mathematical pie, and edible pie.
Exactly.
All right.
Have a great night, guys.
Have a great night. Thank you for calling in and watching.
Woohoo!